What causes gravity? Part 1. What causes gravity? This is what this video is all about. Now, if you're 100% sold on multiple dimensions and multiple universes, you're not going to give this video any chance because your minds are already closed and you're afraid to cross the grain of mainstream thought. Well, I'm not, because if history has taught us anything, it's that sometimes things come from strange and unexpected places. And if you really look and study the reasoning, the numbers, and the possibilities, I might just be onto something. I'm no genius, and I make mistakes in calculations. But suppose my overall idea can open up a door to a room where the real answers lie. And if you give this video and its equations a real honest look, you will see that my idea or theory doesn't disagree with Newton or Einstein, but it just deviates a little and provides a different explanation of what could be possibly causing gravity. Don't be afraid. Take a real hard, honest look at the numbers and equations. What do you have to lose? A little time, and stop thinking these multiple dimension and universes theorists have all the answers, and you might look like an idiot if you disagree or cross their paths. Being wrong is no sin, but not trying is unforgivable. So don't judge a book by its cover, but by its true content. So I look forward to your comments, good or bad. Call me an idiot if you like, but don't say I don't care about our future and that I didn't try. Did I lay idle, timid, and afraid to cross the mainstream of thought?
In order to make this video under 10 minutes, a lot of it I'll just let you read, and you can pause and look over it and study the formulas and what I'm trying to say at your own pace. Here is just where we're taking the force of gravity and equating it to the centripetal force, and this is what it does, and you end up here. And just go through it at your own pace. Here's just where I'm showing you for right now what the value of my new variable n is and what I'm applying to the force of the gravitational constant. Instead of this is what it's known as, but I'm trying to show you how I come up with a little bit different. Well, this is like Kepler's 3 laws here, and this is his third law here, which I'm going to show you in the next frame, that I'm going to equate using my new variable n, and you'll see it. So now in this part I'm showing you Kepler's third law, time squared, or the period squared over the radius cubed, and I'm showing you how the units and how they're going to cancel out, and my value here is going to equal that value there. Here I'm going to show you where I can take Stromann's equation and use some of my formulas here and make it equal Einstein's equation. Remember earlier on I showed you my mass for the sun equation and how I'm taking the t squared and I'm using my n squared and the value of the g that I assigned. Well, here I'm just taking the mass out of Stromann's equation, and this is how I did it for the sun. And now here I take it and I'm reinstituting my t squared value times squared right here, and then when you come back you end up with Einstein's equation. And if you use all the units, they all cancel out, and this is the units for gravitational constant g, and this is units for my new n squared, and they all cancel out. And I said like the fourth thing I was going to show you that I could equate, use some of my equations and equate Hubble's constant to something I was doing. And if I took, this is what Hubble's constant would equal, and if I used some of my stuff and I did that and the n squared, I would come out with these figures here. But the only problem I have with it, I can get a value pretty darn close, but I just can't get the units to cancel out. And these next few frames here, I'll just let you read over it and study it, but I'm going to show you how I come up with my value for the gravitational constant and how I end up with my value for N also. Here again, I'll just let you look over it and study it, but and just kind of follow along. You'll see. And here again, if you look at, if you just took the summation of diminishing squares, like n squared minus x squared, and you start off with n to infinity, but we're not going to infinity. I'm just going up to the power of 10, I believe. You start at x equals 0, and you just keep subtracting, you add them up. Well, by the time you get to 10 first power, 10 to second power, 10 to third power, 10 to fourth power, that's what you get. Well, we're going up to about the 10 to the 10th power to get the value of mine, but then we're going to divide it. You'll see later on. This was the other equation. It's a little bit different. It's just a difference in the where the decimal place is. No decimal here and no decimal place in these. Here I'm just trying to equate the centrifugal acceleration in like my diminishing squares I keep talking about. And here's that formula again. And like I said, it's got to be the diversion force is coming inward. Well, in this frame here, I'm just kind of showing you the hydrogen atom. And remember the first formula I had for the mass of the sun? Well, this G and N squared and all I keep talking about, it's like an inward divergent force. I'm like the fusion is what I'm trying to say. But I'm thinking that fusion in the sun and gravity might be interconnected. Here again in this frame, I'm just trying to show like this divergent force I'm talking about. See how the diminishing squares keep coming in? Diminishing squares keep coming in. Now in this one, I'm trying to show you what the value of G is. And earlier I showed you how I got it with a summation of diminishing squares. And here's the value for N, because if I took it, see, this would be the N factor right here. Like I'm saying, the G factor is pulling things up to here, and then this N factor, N squared factor, is pulling things up to here. And it's kind of funny that see, the 2/3 times 10 minus 11th equals the same thing as the G I assigned to it. Whether it's your quark, well, it's actually supposed to be a minus 1/3, but it's kind of funny how the 2/3 charge on a quark, and you got a kind of 2/3 there. And this is the value N that I assigned for like a hydrogen atom, like the fusion of the sun. But I believe there's a fusion process going on even in our planets. You see earthquakes and volcanic activity that's been present in the past or sometime. Well, if it's like that and we still got some fusion going in the Earth, this would be the value for N on the Earth. So what I'm really trying to say, I'm trying to equate that maybe fusion and gravity are the same thing. Maybe it happens in the sun because mostly it's hydrogen, but on the Earth it's probably happening. On the Moon and other places it's probably happening, but it's not happening at the same power level, because of the makeup. Like the sun's got more hydrogen, we got different elements and stuff. But my whole idea is that maybe instead of multiple universes and multiple galaxies and multiple dimensions, maybe we could go backwards the other way. We could take things from 3 dimensions, go down to 2, and then from 2 we go down to 1 dimension. And maybe this, like this Higgs field and stuff they talk about all around, maybe it's just a one-dimensional thing. Maybe that's the dark energy pushing things apart. Well, anyhow, thank you.